we get when we toss a coin?
Heads or tails?
Correct. So tossing a coin is an experiment. We know the outcome in advance. We know we won't get anything other than head or tail, right? So what is the outcome here? It is head or tail. Correct? What about throwing a die? If I talk about experiment, throwing a die, what are the outcomes I get?
1, 2, 3, 4, 5, 6.
Yes, I will not get more than that. I will get, so I will write it in a set. This is a set format I am writing. Collection of numbers. Should I write more here? You understood what is the experiment? Any operation which can give you a well-defined outcomes. I know the outcomes before. I'll not get any other outcomes other than these outcomes, right? Do you agree with this? Do you agree with this experiment? What if I toss 2 coins?
2 times head, 2 times tail.
I will write the outcome as, I might get head, or I might get, I'm tossing 2 coins here, head, tail, or I can get tail, head, or I can get tail, tail. So you might be wondering why ma'am is writing this way. Just a pattern here, I want you to observe. H and T, I have 1 time. H and T, it's again repeating here, I have 1 time. 2H and 2 T's. So this combination is very important when you go for 3 coins. So that's why I have written like this, so that you will remember the pattern here. Is this clear? So what is the experiment? Any operation, these are the operations what we are performing, which has a well-defined outcomes. That is an experiment. So this year, what you are learning will be a empirical probability. Okay, so I'll tell you what is the difference. So is experiment and outcome clear? What is experiment and what is outcome?
Yes, ma'am.
Yes, ma'am.
Any other event you people know, anything is discussed in your school?
Cards thing.
Cards, and also I have a bag in which all different color of balls are there. Picking a ball from a bag. Picking a ball from bag of balls. Correct? I know, for example, I know there are some red, green and white balls. So will I know the outcome well hand? Either I get a red ball or white ball and blue balls. I know what all balls are there in the bag. I will know that in advance. Will I know the outcome in that case? Yes. Any other experiment discussed in your school? Suppose you have a numbered card. You have a numbered card. You have a numbered card. You have 10 cards with 10 numbers, 1 to 10. Do I have the outcomes well defined?
No, ma'am.
No. Just imagine you have a collection of cards. You have 10 cards. On that, they are numbered cards. Numbers are written on top of that. Something like this. This is given to you. This is an experiment. You're picking up a card. So will I have outcomes well defined before? I can get either the cards in that set. So these are all your experiments where the outcomes are known well before. We know the outcomes, what we will get, but we don't know what we'll get at that time. But we know we'll get in that set itself. Is this clear? I hope.
Yes, ma'am.
I hope experiment is clear. Outcomes.
Yes, ma'am.
Okay. Now, this year you have empirical probability. This is the main concept and it is a very easy concept here. Next year you will have experimental probability. So this year you have empirical probability. What is this empirical probability? Suppose we perform an operation or experiment, number of trials. Okay, just write down this definition. So N is total number of trials. Total number of trials. I'll tell you what is it. The empirical probability of an event happening is given by number of trials in which event happened divided by total number of trials. Just write down this. This year, it is mainly on the empirical probability. Next year, you have experimental probability. So you should not forget if I'm talking about probability next year. So just write down this. So this year, you have mainly focus on empirical probability. We'll just discuss a case here. Noted till here?
No, ma'am.
Just a minute, ma'am.
It's a very easy topic and it is something like marks in your pocket type subject. You know, this subject is so good. Confirmed you will get marks in this chapter if you do it in a proper way with no careless mistake, writing down the numbers properly. So this is empirical probability. So we have number of trials we do and we take the number of trials in which the favorable event has happened. We'll do this. Note down this thing, note down this definition. Done? Deepta, understanding right?
Yeah, ma'am.
And what about Jia? Any doubts, Jia?
No, ma'am, no doubts.
No? So shall I continue now?
Yes, ma'am.
Yeah. Now just imagine you're tossing a coin 2,500 times. You're tossing it. Okay, number of trials. This is total number of trials. In this 2,500, you will get 1,600 times, you will get heads. What is the remaining time you get tails? What is the remaining times? Out of 2,500, you are getting head 1,600. The remaining will be tails, right? What is it? Can you give me the figure here?
900.
1,900, yes. So 2,500 trials were done.
Ma'am,
Tossed.
900, ma'am.
Yes?
900, ma'am.
900, okay.
900.
So out of 2,500, 1,600 is what you're getting heads and remaining 900 times you're getting tails. What is, if a coin is tossed randomly, what is the probability of getting a head? The question will be, what is the probability of getting a head? How many times head has occurred? In which event has happened? I want head. How many times head has occurred?
1,600.
How many times trials are done? Simplify this. How much do you get? Number of time heads coming up. When you toss a coin, heads comes up. That is what 1,600 times heads had come up. So 1,600 by 2,500. How much is that?
0.64.
0.64. Always probability has to be expressed in decimal form. And it will be always less than 1. Is it clear? Empirical probability,
Yes,
the
ma'am.
trial.
Yes, ma'am.
Yeah, now I want you to calculate probability of getting tail. What is probability of getting a tail now? How many times tail has occurred?
900 times.
900.
900 times. How many times trial is done?
2500.
2500 times.
What is that simplified now? 9 by 25.
0.36.
0.36. Now, we know head will occur, tail will occur. If just observe, I want you to observe one thing. This is only two events happening. What are the two events happening in this experiment? These are the events happening. Head or tail. What is probability of first event? 0.6.
0.64.
What is probability of the second event?
0.36.
What do you observe when you add these two events? What do you get?
1.
1.
See, this experiment has only two events. So when I add these two events, what do you observe here? You always get 1. Whenever you add the individual probability, you observe that the addition is 1. Is this observation clear?
Yes,
Ma'am,
Mr.
if the result does not come, it is an impossible event, right?
Yeah, if that we'll talk about impossible event and sure event. Right now, we are talking about experiment, number of trials, and we are now talking about event. So what is this event? Getting head or tail. Getting a head is an event. Getting a tail is an event. Understood what is meant by event? Yes. Event is a outcome which can occur. How many events throwing a die will have?
6, ma'am.
6 events. How many events tossing 2 coins will have?
2 events.
2, ma'am.
2 events or 4 events?
4.
Tossing 2 coins.
4 events.
4
No, ma'am.
events. So